Good evening everybody and welcome to the video. In this video, I'm gonna be talking about the architecture part. So here I'll be talking about how we switched from MongoDB streams to AWS Event Bridge global endpoints for resiliency and literally zero downtime and high availability, essentially going multi-region. So let me share the architecture with you. So I'm gonna share the old architecture that we had. So here you can see I did publish this article in the March. So here we had MongoDB. We were bringing in data through MongoDB via streams into Event Bridge, and from there SQS and Lambda and into S3, and of course then we were querying data into the data lake via Athena. This architecture is great, but what we see here is instead we wanted to have MongoDB and S3 as a subscriber. So what's happening is here the primary producers are producing messages and they're inserting into MongoDB, and then using streams we are bringing that into the downstream application. But what I really wanted, or what we really wanted, was the producer producing messages to the main bus, and then Mongo and S3 becomes a subscriber. Now get ready for a multi-region architecture. This is it. So this architecture is designed for resiliency. This architecture is designed for zero downtime, can handle millions of requests. Let me walk you over the architecture. So now the producers are going to produce messages to this global endpoint, Event Bridge global endpoint. And depending upon, again, the latency, US East 1 is our primary region. So the messages will be routed to the primary US East 1, right? And here what's going to happen is we have an SQS and a Lambda, right? So the messages are going to be entering into the SQS, and the Lambda is going to take messages in batches. For each messages, it's going to process, it's going to normalize, it's going to add the unique identifier and object ID. And then essentially this Lambda will publish on a main event bus. This is an internal raw event bus, and from there we publish the message to the main event bus. Anything that fails goes to the dead letter queue and followed by a Lambda into S3. So we essentially archive the failed messages into S3. Now what happens is over here, watch my mouse. So once the messages are there in the main event bus, we have two subscribers. So there are two SQS queue and two Lambdas. One Lambda is basically a subscriber for S3. So now S3 is a subscriber. MongoDB is a subscriber. So each subscriber has its own queue. So here the messages are going to come to this SQS queue. The Lambda is going to denormalize and essentially flatten the data structure, and then essentially going to put on the S3. The MongoDB will essentially take the data, batch the data, and then essentially gonna put into the MongoDB. So here you can see, instead of this architecture where we were producing and inserting into Mongo and then bringing into the data lake, now what we are doing here is all the producer gonna produce messages to the main event, that is a global Event Bridge global endpoint, and then S3 and MongoDB becomes essentially the subscriber. Now anytime while inserting message into S3 or Mongo, if anything fails, each subscriber has its own dead letter queue, and whenever messages go in the dead letter, a Lambda is fired, and then we essentially archive it into the S3. Then we have a batch job which runs every single day and checks the S3. If there are any failed messages, it's going to reprocess and essentially insert those messages direct into S3. Same goes for MongoDB. If anything is failed, it essentially is archived on the S3, and a batch job will essentially take the failed messages and essentially retry into MongoDB. Now the same architecture is replicated into a second region, that is region 2, US to S2. So anytime the latency or the region is not healthy, automatically all this traffic is going to flow to this region, which is essentially in the orange color. So now you can see how we are now leveraging AWS Event Bridge global endpoints, right? Again, truly at scale, right? And now here my Mongo and S3 are a subscriber. So anytime I want to subscribe, or anybody who wants to subscribe data, they can simply subscribe the data or add their subscription on the main event bus. Here, this is an internal bus, right, which will receive messages, does some pre-processing, and then main bus is where the subscribers will essentially subscribe for events or messages. This architecture is resilient. This architecture is built for scale. Again, zero downtime, because anytime a region goes down, all the traffic goes to a different region. So failover, right? So we are using AWS Event Bridge Global Endpoints, which is pretty new, released very recently, and we started essentially adopting. So now this architecture that we had, where producers are gonna produce to the Mongo, and using streams we are bringing into Event Bridge and then essentially to S3. Now it becomes much easier. Producer will produce to the global endpoint, and then essentially MongoDB S3 are a subscriber. Tomorrow, if I want to add a subscriber for Aurora, I could do that. I want to add a subscriber for Dynamo, I could do that. Any teams can easily subscribe to the data that they want. And again, both the subscribers are going to be deployed in both the regions, because we want to have zero downtime, right? Anytime the latency is low, automatically the traffic moves to a different region. So this is how we essentially use Event Bridge global endpoints to power our downstream user. Let me know if you have any questions in the comment section, and I'll be more than happy to answer your questions. Thank you so much, and I'll see you guys in the next video.